Okay, so the recording is starting. Good morning, everyone, and thank you for being here. My name is Giulio Castelli, and I'm a researcher at the University of Florence. Today, we are sharing with you the third masterclass of our project, AG-WaMED, which is funded by the Prima Foundation, Section 2. And we are very happy to realize this activity together with two other projects, AGREEMAR and AGREEMED. And we hope this will be a start of a nice cooperation. The masterclass will be structured in 3 interventions, but first and foremost, I will leave the floor to the coordinator of AG-WaMED project, Professor Elena Bresci, for an introduction. Thank you.
Thank you, Giulio. Thank you very much. It's really a pleasure to be part of this masterclass where we have already more than 30 people participating. And the added value of this masterclass with respect to the previous one is that we are joining in this masterclass 2 other project results. So the other 2 interventions will be given by the reporting the results of the AGREEMAR and AGREEMED. So as Giulio said, I hope that this is the starting of proficuous collaboration even after the end of the projects, that for all the 3 projects will be by, let's say, the end of 2025. So we prepared some slides that I will share with you. I hope you can see it. So first of all, since the masterclass is on non-conventional water, we will give you a definition of what we mean, because you can find a lot of definition, but the one that we adopted is the following. So unconventional or non-conventional water resources are defined as those coming by products of particular processes, may need suitable pre-use treatment and require on-farm management activities peculiar for that quality of the water when they are used for irrigation, or are the water that can result from specific techniques to collect water. So in particular, we are referring to techniques that are capturing rainfall or runoff by water harvesting. So some examples are desalination, seawater or breakwater, wastewater from domestic, municipal and industrial activities, or agricultural drainage water or water harvesting. The 3 Prima projects that are on non-conventional water use, and we realize that this network are AG-WaMED, that I am coordinating, so advancing non-conventional water management for innovative climate resilient water governance in the Mediterranean area. AGREEMAR, adaptive agreements on benefits sharing for managed aquifer recharge in the Mediterranean region. And AGREEMED, innovative aquifers governance for resilient water management and sustainable ecosystems in stressed Mediterranean agricultural areas. So as we can understand from these 3 titles, we have a common lines that are non-conventional water and the Mediterranean. So these are the reasons why we decided to create this network for sharing and working together. And the other common factor is that they have been all financed by the Partnership on Research and Innovation in the Mediterranean Area, so PRIMA. That is a public institutionalized European partnership between the European Union and participating states, because the funds for this project are coming from the European Union, but through national funding agency. So all the three projects as demo sites, both you could say in the north of the Mediterranean and south of the Mediterranean. So AG-WaMED relies on 4 living labs, one in Italy, in particular in Tuscany, in Valdorcia, one in Spain, the Segura River Basin, one watershed that is a transboundary between Tunisia and Algeria, and is the Wadi El Kabir, and one in Egypt that is the Wadi Nagamish. AGREEMAR has regional demo sites in Portugal, the region of Alentejo and Algarve, in Spain, the Eucar Water District, in Cyprus, or the Republic of Cyprus, and Tunisia, the Chiba watershed. And AGREEMED in Jordan, the Jordan Valley, in Morocco, the Souss Moussa Basin, and in Tunisia, the Hammamet region. So the non-conventional water that has been considered in AG-WaMED are different for all the 4 living labs. In particular, in Italy, we explore the use of small agricultural reservoirs for water harvesting, that they are now underutilized, and instead there is a very big interest for rehabilitating the numerous, almost 1,000 small agricultural reservoirs that are in the region because of a measure for adaptation to climate change. In Spain, in the Segura River Basin, the irrigation water resources comes from wastewater treatment plants and a desalination plant, but still these non-conventional water sources are not enough. In Tunisia and Algeria, has been utilized some water harvesting structures and flood diversion for managed aquifer recharge, and in Egypt, mainly cistern and desalination process. For AGREEMAR, the main aim was the feasibility mapping of a managed aquifer recharge in all sites. So the common method was the managed aquifer recharge that has been explored in the 4 different demo sites. So in Portugal and Spain, Cyprus, and Tunisia. I'm not going through that because I'm sure that it is going to be presented by all the project. So in AGREEMED, the same, the 3 different demo sites were Jordan, Morocco, and Tunisia. What we learned from joining the efforts among our project, that they are all, let's say, relying also on a participatory approach. In fact, AG-WaMED is based on living labs, where we applied the RRI, so Responsible Research and Innovation Roadmap, within at least 4 workshops that has been carried out in the 4 living labs, where stakeholders were together for discussing and proposing solutions or identifying problems that would have been explored and discussed in the following workshop. In AGREEMAR, we had the same co-creation of a general governance framework, and it has been implemented, the participative multi-actor approach for increasing the involvement and the participation of the stakeholders. And in AGREEMED, the same, demo sites has been implemented with the involvement and participation of local institutions, also education and training activities, and also socioeconomic analysis for potential investment and market opportunities. Here are some examples of meetings that has been made in the different projects, where, as I said, stakeholders coming from different field, for example, public, private sector, or a public institution, research centers, or farmers, were present and we are discussing. Here are also some other examples from AGREEMAR, and here examples from AGREEMED. So we see how the importance to be all together in one place for trying to outline which are the problems and the possible solution to the problems that has been identified through the participatory approach, and in particular through a bottom-up method. So some common results or consideration that has been identified and coming from the three experiences are the following. The first one is that the stakeholders' involvement is fundamental for having results, and is fundamental to keep the attention high and the interest high on the activities of the project, because obviously there are the partners that are working on the project, but the stakeholders are the source of our information. So we need to keep them updated and feeling and make them feeling really part of the project. We recognize also, in fact, that it's very important to involve them from the beginning of the project, and also, it would be recommended if some main stakeholders that are going to be considered should be involved even in the preparing of the proposal. So before knowing that the project would have been financed. The second observation that we made is that technology is available. So we have a lot of, let's say, solution, but the implementation in real life needs tests and should be learned from something that maybe is not working for some reasons that has been identified. Land degradation is a common problem, and associated with the water access and then water sustainability. We need to focus or reverse the process of land degradation, considering which are the practices that instead are more appropriate for that area. The importance of social and economic sustainability has been recognized by all the three projects, and also the importance of considering non-conventional water resources with the managed aquifer recharge. So the utilization of artificial recharging of the aquifer for getting more availability of water and considered as integrated with non-conventional water. Which are by now the activities that has been made and what we would like to go or to do together in the future. First of all, we participate in a joint, we participated to the Arab Land Conference in February, presenting a talk jointly. So I have been actually the presenter over there, and we presented the results of the main results of the three projects. We will have another appointment in late April. That is the AGU conference in Vienna. And there will be a splinter meeting that has been proposed and accepted by the coordinators of the project. So this is another opportunity that we may have to discuss not only the results of the project, but also what we learn from the project and which will be our programs for the future. So future activities that we are planning for the future are trying to organize the final event, at least of AG-WaMED, together with the other two projects, because we think that this is a way for being much more strong, let's say, in the spreading and the dissemination of the results. We can also work on joint publication, even if obviously we will not have the papers published by the end of the project, because the time is quite short for all of us, for all the three projects. And another proposal that we would like to to explore is the creation of a platform or a working group on non-conventional water use, since the subject is very recognized that an important subject in, I would say, not only in the Mediterranean, but also at world level. So why don't try to explore collaboration with other institutions that are not those that are already working on conventional water in the three project. So here you can find the references of the financing national agency for each project. And I'll stop here for this short presentation, and I will just a quick overview of the agenda. So the masterclass has been divided into 3 parts, and it has been devoted 45 minutes to each project. So AGREEMed will start with Soufiane Taia, and then there will be some 15 minutes for a question and answer. Then the following at 10:30, it will be AGREEMAR with the Catalin Stefan, and the same 15 minutes for question and answer. And the last one will be AG-WaMED. So remember that the important, let's say, of question and answer, the time, because it's very important to us to also explore how is the effect or how is the impact of what we are talking about. So you can use the chat for the question, and they will be collected at the end, and there will be time for answering. So I'll thank you very much. I wish you a good time shared with us for all the duration of the masterclass. Thank you very much.
Thank you, Elena. And it would be a pleasure for me and my colleagues Eleonora Forzini and Lorenzo Villani to moderate the next 3 sessions. So I would like to invite to the floor Soufiane Taia, Assistant Professor at the National Thematic Institute for Water Research, University Ibn Zohr, Agadir, Morocco, for his keynote on the AGREEMed project. The floor is yours, Soufiane, and thank you so much.
Thank you, Luca, for these words. So I hope you are all doing well. I will try to share my screen. So this is it. Okay, now it's on full screen. Okay, thank you very much. My name is Soufiane Taia, and I'm an assistant professor in rural engineering and water resources at the National Thematic Institute for Water Research in Morocco. It's a great pleasure to be here today and have the opportunity to share insights from our projects into this initiative. Our project, AGREEMed, which aims to test and implement integrated approaches for water management in Mediterranean region, and also address critical challenges of water scarcity, climate change, and sustainable agriculture in those regions. So first of all, AGREEMed is all about strengthening the ability of water stakeholders to develop and implement aquifer management plans in the Mediterranean region. Our objective is to ensure smarter, more sustainable groundwater use by focusing on key areas in the Mediterranean region. First, we aim to improve the scientific knowledge by providing precise insights into how groundwater and systems work. Also to help to help decision makers to shape better policies and decisions, and also to evaluate the best practices for managing non-conventional water sources. In our project also, we are trying to test and demonstrate brine management, water brine management, as well as the nature-based solutions, such as recharging aquifers with treated wastewater, reusing it for agriculture to reduce pressure on groundwater. Also, we are trying to develop a support tool with data-driven solutions to support sustainable solutions that benefit both the environment and also the local communities. Finally, we believe in scaling up successful strategies through workshops, public outreach, and also collaborations. We are aiming to share our findings and make a larger impact. So, AGREEMed conceptual framework is inspired from the assumption that a combination of scientific and technological advances, along with dialogue and ecosystem integration, which are very important for adaptive aquifer governance and sustainable agricultural development. This project will deal with major issues in the Mediterranean basins through assessment and analysis, and also will take advantage of knowledge and data to deliver innovative solutions for aquifer governance and also for agricultural development. So in this project, we have like 3 pilots area, which are the Sousse in Morocco, Hammamet in Tunisia, and Jordan Valley in Jordan. Those pilot areas have been selected because they represent the most sorry. Sorry, thoughts. I need to drink. The pilot area have been selected because they commonly represent water issues found in the southern Mediterranean region in general. So in the first stage, our focus is on understanding and improving groundwater management by first updating the baseline, which means assessing the current stage of groundwater in our pilot basins, and also looking at both quantity and quality. By doing this, we establish a solid foundation for to guide our future actions. In the next step, we work on enhancing our knowledge on aquifer processes. This step involves identifying important factors such as the influence on groundwater conditions, including recharge, salinizations, and overexploitation. A better understanding of those issues will allow us to develop strategies and to protect and sustain groundwater resources. Finally, we are trying to project the future states by gathering data and improving insights, and also by modeling and predicting how groundwater will evolve under changing climate conditions, and also this will include its availability as a strategic resource, and also the impact on surrounding ecosystems and environments. To effectively manage groundwater resources, we need a scientific knowledge that combines both data collection and advanced modeling. We start with data collections using multiple sources, from ground measurement to remote sensing data. We also proceed with advanced hydrological modeling, such as SWAT ModFlow, which helps to simulate the groundwater recharge and the flow dynamics. And also, we used the different scenarios from SSP and RCP models to project the future conditions of the groundwater, and as well as the surface water resource. And also, we try to understand the land use and land cover changing by analyzing how urbanization and agricultural expansion affect also those resources. So let's start by the non-conventional water solutions. We first evaluated the current state of our non-conventional water resources in those regions. In this step, we collected and analyzed data on those technologies, and also we developed an evaluation matrix for screening and selection, and also incorporating the technological expertise and also the experience of stakeholders in our analysis. So we have selected a range of technologies at our disposal for non-conventional water use. Firstly, desalination. Then we also explored the water reuse, groundwater stored in the aquifers, also as an important resource, particularly in arid regions. On the other hand, the reuse of treated wastewater for irrigation purposes, for example. Moreover, with adapted irrigation systems like drip irrigation, trying to maximize water use efficiency. Furthermore, we could stand out for some promising methods such as cloud seeding, dew water, and also fog water. Those methods also provide a supplementary water sources in area with high humidity and or also fog occurrence, and also hard conditions like in mountains and etc. So to evaluate and those non-conventional water resources, we used we categorize indicators into 5 main groups. The first group is like the availability. Second is the application, which address the utilization of those processes in drinking or irrigation, and also the environmental impact of using or exploiting those resources, and also the scalability of those techniques, and as well as the economical sides, which also consider the capital and operational costs, as well as the product cost of those of using those technologies. All of those indicators have been selected respecting like a SMART concepts defined by like specific, measurable, attributable, relevant, and also targeted indicators. So we created an evaluation matrix with the technologies and the selected indicators. we have developed these evaluation matrix, which incorporates both the technologies and the chosen indicators. Those technologies are like systematically stored into categories such as availability, applicability, environmental impact, scalability, and economy. This methodological approach has been like collaboratively agreed upon within the consortium and also the stakeholders and engaging partners. So in this part of the project, we try to develop a conceptual and methodological approach by designing a household farm watershed nexus platform, which serves as a decision support tool to assist us in making irrigated farming systems more sustainable. This tool calculates several indicators covering different spatial scales from plot to regional for each tested innovation, and also under different scenarios, climate scenarios, and also market scenarios such as price, inflation, energy, and water quota, for example. The main hypothesis behind this approach is that a better irrigation water allocation will support agricultural systems. So in this part of the project, we focused on optimizing solar power desalination plant with a particular focus on brine management. This initiative targets improving the management of brine water in Jordan and Tunisia. This part of project has like three specific objectives. The first one is aiming to improve the efficiency of existing solar driven brackish water reserve osmosis RO plants. The goal is also to increase the water yield from 50% to 80% by optimizing those plants. A major part of this project is to design and optimize a prototype for each of those two demonstration sites. And finally, we are trying to initiate and promote the transfer of those solutions into practice by collaborating with the stakeholders and ensure the adoption and the good implementation of those prototypes. So first of all, in Jordan, there is like an existing solar power brackish water desalination, which is a reverse osmosis system powered by solar energy, which includes solar panels, batteries, and RO membranes, but faces some challenges with water recovery and energy efficiency. Currently, it recovers 60 to 70% of water, which we aim in these projects to increase to 80% while keeping energy costs low. So for this, we proposed 4 scenarios. The first one is to install solenoid valves in the brine discharge system to control water recovery rates. This will protect membranes, reduce energy use, and better manage brine rejection. In the second scenario, we're trying to eliminate chloride and sodium due to low organic carbon. This will result in a lower environmental impact less membrane fouling, and also reduce the chemical costs. As a third scenario, we propose to add a 4-inch pressure vessel to recover water from the first stage, and also this will increase water recovery to over than 80%, and also will reduce brine discharge and enhance resource efficiency. So as a fourth scenario, we proposed implementing a pressure exchanger to reuse energy from brine for incoming feed water. This will lower energy costs and increase freshwater yield, and make also desalination more cost effective. So after analyzing those four scenarios, the best scenario for improving desalination is scenario 4, using a pressure exchanger, but this method is this method is not adopted in this project because we are planning to implement scenario 3, which means that adding a second RO, because it increased water recovery to over than 80%, aligning with our objectives, and also it can be gradually introduced with low investments. Additionally, our partners team in TOP in Berlin and also Delta are already proposed integrating a new membrane, ensuring like a smooth upgrading to a more efficient RO system. So in the Tunisian sites, our project focuses on Mahfouz farm in the Hammamat Basin in Tunisia, where groundwater salinization is a serious issue. The main causes of desalinization is sea intrusions and also over extraction and over pumping of groundwater, and also the lack of alternative fresh water sources. To cope with this problem, farmers are mixing desalinated water with saline water, or using a treated wastewater. So our goal in this project is to explore the sustainable solutions on how to restore water quality and support local agriculture. So the existing system in this site in Tunisia uses a Vortron module designed for an ultra-low pressure desalinations. It achieves like 99% of salt rejections with an active membrane area of 28 square meter. And an average water output of almost 3 cubic meter per day. So the water production is very low, with only 10% of fresh water converted to of feed water converted to fresh water, while 90% is discharged as brine. Salt retention is also high, which can reach 98% of salt removal, but with a high energy consumption. So the brine concentration is also close to the feed water, meaning that it has the potential to further treatments or reuse. So to deal with this, we introduced 3 scenarios. The first one is optimizing the existing RO systems, which means to implement a multi-tank system for better water separation and reuse, and also to increase treatment capacity and pre-treatment steps to reduce fouling. So this solution also will help us to enhance the efficiency by adding a second RO stage and recirculating concentrated water. And also, we aim to install a drip irrigation to optimize the use of desalinated water. As a second scenario, we proposed alternative brain disposal and valorization. We are trying to explore deep well injections and evaporation ponds, and also surface water discharge if permitted, or irrigated salt plants. And also we proposed implementing a zero liquid discharge or crystallization to extract important salts, and also to use pressure retarded osmosis. This will help us to use the brain for energy recovery. And as a second scenario, we are suggesting to scale up to industrial farm model. So this scenario align with local policies and also develop a long-term business model for sustainable desalinations. But finally, after analysis, we opted for we prioritize the first and the second scenario because our objective is on our focus is on small-scale farmer solutions. So in this project, we also try to explore the nature-based solutions, which offer a sustainable way to manage water resources while benefiting the environment, society, and also the economy of the community. According to the European Commission's, the natural-based solutions are inspired by nature and focus on cost-effective and resilient solutions that improve landscapes and water systems through adopting and making resource-efficient intervention. So the key objectives of those solutions in water resource management is to enhance the groundwater recharge with managed aquifer recharge techniques, and also to improve water quality through constructed wetlands and buffer strip, and also to reduce resilience and conventional wastewater treatment by using natural filtration systems. And those solutions also support climate adaptations by restoring the ecosystems. So one of the great way to treat wastewater naturally is by using the constructed wetlands. This method relies on plants and microorganisms to filter and clean the water before it is reused. So it helps remove harmful substances like nutriments, heavy metals, and pathogens from wastewater, and it also supports biodiversity by creating a healthy wetland ecosystems. In addition, it is a versatile solution that can be used on farms or even at a larger regional scale. Constructed wetlands need space to be effective. This is one of the most important challenges, and also they require like regular maintenance to keep them working properly. So another effective natural-based solution for groundwater is like the managed aquifer recharge. This technique helps replenish groundwater by infiltrating treated wastewater or runoff into aquifer. It also helps to reduce saltwater intrusion, which is a major issue in coastal area. It increases the groundwater storage, making more water available during dry seasons. as one of the biggest challenge is that we need a detailed hydrological studies before trying to implement these solutions and ensure that our aquifer can absorb and store the water safely. So another solution is the buffer strip and free water surface wetlands. Those are strips of vegetation planted along agricultural fields. They help trap sediments, nutrients, and pollutants before they can reach the rivers or lakes. They also reduce pollution runoff from farms, protecting water bodies, and also improve water infiltration and enhance soil health. One of the main challenges is that this solution depends on farmers to adopt those practices, and also requires a great support from stakeholders to be implemented widely. So to determine which natural-based solutions is suitable for each study site, we proceed a study, a feasibility study for them. So our evaluation was based on hydrological, climatic, as well as geological factors. The comparison of those solutions is summarized in this table. For example, constructed wetlands need like a constant flow of wastewater, required moderate to high land use, and also provide high pollutant removals. So the managed aquifer recharge technique also need permeable soil and recharge periods, which require land and monitoring, but also in the same time help recharge groundwater. In the other hand, the buffer strips work in all soil types, need low maintenance, and are effective in reducing runoff pollutions. So we decided that best solutions for each region, for example, for Tunisia in Hammamet watersheds, the managed aquifer recharge is the best choice to tackle saline intrusions. For Jordan in Morocco, there is for Jordan Valley, there is managed aquifer recharge, and also buffer strips are also needed for irrigation and soil conservation. And in Morocco, we stated that the constructed wetlands and also the managed aquifer recharge techniques are suitable because of the severe water scarcity. So we also considered the economical aspect of those nature-based solutions by incorporating the capital cost, the capex, and also the operational cost, opex, to ensure long-term feasibility. In general, buffer strips are most cost-effective, while the managed aquifer recharge is the highest cost, but it can provide long-term water security. Choosing also the solution depends on available resource, environmental needs, and also the long-term benefits. So in this project, our goal is extend to share knowledge and expand those solutions. So in this project, we try to keep everything running smoothly through effective management and also through collaboration and partnership that involve all kind of stakeholders, which help us to develop suitable innovations for all type of stakeholders. So for water treatment and green management, we organized several workshops at the demonstration sites. Those workshops are supposed to share practical solutions and also to demonstrate to local farmers and policymakers the benefits and also the conceptual guideline of those techniques. We also worked on engaging communities and also policymakers to support the new and innovative ideas. And also those results, all of those results are going, most of those results are published already, and some further publications are still under review, and also those results have been communicated in several international conferences and local workshops to ensure that our solutions and are widely adopted and put into practices. And thank you very much for your attention. I hope that
Thank you so much, Soufiane. Perfect timing, and thank you so much for giving an overview of the actions of the AGREEMed project. And very interesting to see the level of detail analysis that you did for some of the technologies, the brine treatment and the natural-based solution. Now I would like to open up the floor to any questions from the audience. You can pose your... Oh, okay. We have a first question here. I think I saw a hand raised. Please go ahead. Hemon, was it? No, wait.
So I don't hear you.
No, I was waiting for someone to pose the questions, but maybe it was a raised hand by mistake.
Okay.
Perhaps. Let's check. I'm checking also the chat, whether there are any questions. Otherwise, I might have one, actually, if you don't mind. I heard how you involved some of the local stakeholders in the project. Which methods or approaches did you use to do that? How did you involve them? Is it like workshops or?
Yeah, in this project we tried all of those techniques. We tried workshops for promoting the green management solutions and also the NBS, and also we tried several techniques, several other techniques like dissemination activities in conferences and meetings, such as we tried to be inclusive in our approaches. So
okay, thank you. I see a questions from Catalin. Stefan, please go ahead.
Soufiane, thank you so much for introducing the project. I was very interested in your presentation, and congratulations for all the work that was done until now. You mentioned in one slide the costs estimation, and I would be very interested to learn more how the costs were estimated. And if the time doesn't allow now, would you please share with me maybe some reports, or is there any deliverable available regarding the costs analysis?
Yeah, thank you very much for your question. Yeah, there is like there is a cost analysis reports, there is internal reports, and there is like the public reports. You can find in the websites, AGREEMed, in our websites, all the reports and documents that details the cost analysis and the economical study of those solutions. If you
Thank you very much.
Yeah, if you can note the websites, then you can visit it later. And if you have any other question, I'm happy to share with you all possible informations.
Thank you. Any other questions from the audience? Yes, we have one from Rohina. I don't know if you want to pose it yourself and unmute, or I can read it. Rohina Bauer. I'm going to read their question, which is, how do you involve the community? And do you have a regular reporting system? If so, where do you report your findings? Thank you for the question.
Yeah, thank you. We have developed actually a dissemination plan within the one of our packages, one of our most important work packages, which is upscaling and dissemination and exploitations, and through several actions, we have made it to develop a huge network of dissemination. There is like social media and also websites, and also which we are trying to disseminate our results into conferences and communications, and also the most important thing is the peer-reviewed papers. We have like several published papers. You can just find them in our website. I don't know if I answered successfully to your question.
I think it was a good answer. Let's see if there is another follow-up questions. But actually, there is one more coming up from the audience, from P. Congratulations for the work realized. Is the presented DST available for use or consultation?
Yeah, for now, we are still developing this tool, so it's not finalized yet. So we are in the process on working on it. So it will be available in the end of the project by the end of 2025. Yeah.
Thank you. Now we have another hand raised by Hemon Kumar Saha. Please go ahead if you want to pose your question.
Thank you, Soufiane, for your nice presentation. Actually, I am a bit things about the RO. You have described the RO, ZLD, etc. Basically, the brine management system. So when you are actually implementing these things like solar-based RO system or ZLD or brine management system, is the farmers who actually is a position of a great stakeholder, are they ready to adopt these technologies, and how they will implement? How we are going to integrate this ZLD or RO with the farmers, or it will be in a different institutional basis? Am I clear with my question?
I will try to answer and see if it's my answer can it's clear. So we are firstly we are in these projects, one of the most important thing is prototyping. So we are doing a prototype of the solutions we are adopting. So first of all, we just try to implement and test if this solution is effective, and then we are trying to make this technique transferable, and also sharing all of our results and disseminating those practices with all of the other farmers. But firstly, we do the prototype and make sure this prototype works fine and it is successful. Then we disseminate all of the techniques and the results to the other farmers via workshops and fairs, etc. Yeah.
Okay. Thank you. Do you have any follow-up question, Hemon, or is that okay?
No, it's okay. It's quite okay. But now I'm clear. Okay, I got it. Thank you so much. Thank you for the answer.
Thank you. And I see a comments by Catalin, Stefan in the chat. If you wanna have a look at this, Soufiane, even in a few minutes, it's about the costs analysis.
This can be discussed also by email, so thank you for the presentation. I think don't need to discuss it. I couldn't find the information just quickly, so I would maybe need a bit of help to identify that report if it's publicly available. But maybe I have a quick other question, or is maybe a comment. The AGREEMAR project is organizing the final meeting in Hammamet between 6th and 11th of April. And you mentioned that one of the case studies in your project is also that. I was wondering if maybe there is somebody available to meet our group and maybe to have a quick introduction of the case study. We have planned a field trip because we are going to visit also our case study, which is very close to Hammamet, is the Chiba watershed, and especially the Korba wastewater treatment plant, where we have a managed aquifer recharge system installed. So I was wondering if we could maybe allocate a bit time to meet your team there and expand also the collaboration, discuss with you about the two projects.
Yeah, thank you, Catalin. Yeah, of course, we can try to for our colleagues in Tunisia. We can try with them if they are available to meet with you and discuss maybe future collaborations. You can just send me an email. I will send you the my email and also the project email, so you can send us this email for future collaboration, and we try to find a solution for this meeting. Yeah,
thank you very much.
A pleasure. Yeah, thank you.
Okay. Well, thank you again very much, Soufiane, for the presentation and the Q&A. I think we can now move on to the next session. And before doing that, I just let all the participants know that the recording and the presentations will be available on the website, AG-WaMED project, and also on the AG-WaMED YouTube channel. So the next session will be about the AGREEMAR project. So I would like to invite to the floor Catalin Stefan, Research Associate at the Technischen Universität Dresden, for his presentation.
Thank you very much. Is the slide showing okay?
Yes.
Can you
yes,
see the
please.
presentation? Okay, perfect.
Yes.
Well, I would like to first thank Elena, Giulio, and the entire team for this initiative. It's great to see these networking efforts, and I really appreciate it. Also, the previous invitations to join the two other Prima projects. Very much appreciated, and thank you very much for that. My name is Catalin Stefan. I'm working at the Technical University in Dresden, in Germany. So I guess the first question you might have is why I'm in this meeting at all? Because Germany is not a Mediterranean country. So why is Germany actually participating? I ask also the project agencies the same question, and actually we are also very much affected by climate change in Central Europe, let's say. Maybe not to the extent that you have in the Mediterranean basin, but this is going to be probably coming in the next years. So we'd like to prepare ourselves. We'd like to learn also from you, because there is a lot of knowledge that is shared between the Mediterranean countries that Central and, let's say, Western Europe could benefit. Especially in this case, in our situation regarding the potential use of non-conventional waters. Particular case of treated wastewater, the regulations are extremely strict here, and it is actually not possible at all to use treated wastewater for groundwater recharge. Exceptions are very rare and under very strict conditions, and it's even difficult for research purposes. That's why collecting evidence and designing, let's say, technical and non-technical frameworks for managed aquifer recharge using non-conventional waters and bringing evidence to the stakeholders, that's very much interesting for us as it is also for you. So I'm happy to be and honored to be the coordinator of this project, which is called Adaptive Agreements and Benefit Sharing for Managed Aquifer Recharge. And just from the title, you might have already an idea what the project is about, hopefully. So we're talking about agreements, we're talking about benefits, and we're talking about managed aquifer recharge. Soufiane explained briefly what managed aquifer recharge is. This is actually the focus of our project, the technical solution that we implement. And as you might see it also in this slide, different water sources can be used. We're talking about natural water sources, that's just surface runoff, rivers, surface water bodies, and so on. But we also talk about treated wastewater as potential use. And the examples of managed aquifer recharge, they are showing evidence that managed aquifer recharge was successfully used until now, and it's in a continuous expanding trend. There is a website that we developed together with AGREEMed in the Netherlands, where there are about 1,000 case studies on managed aquifer recharge, and each of these dots represent one MAR site. And there are also documents and references attached to it, so you could see that there is a lot of experience. However, Northern Africa, I would say, is not that much represented in this database, which is not exhaustive, it's not complete, but just, let's say, some examples might be present, but there is still a lot of potential. And although we have actually evidence and we have confidence in many parts of the world, there are still challenges remaining that need to be overcome. And from my experience working in managed aquifer recharge for the past decades, I could see a lot of non-technical challenges, for example, related to the character of managed aquifer recharge. We have connections between different water bodies, rivers, aquifers, other surface water bodies, wastewater treatment plants. So there is a multi-use water context, therefore also competing interests. When we take water from one user and let's say store it underground, there might be already conflicts at the water source, but also conflicts of who is benefiting from this project, because not always the same user infiltrates the water and also use it afterwards. So there are also agreements needed for, let's say, sharing the benefits resulted from managed aquifer recharge. We have public mistrust. People are not convinced that this is safe. They are questioning always the reliability and the potential pollution pathways to the aquifers. Therefore, and this is also because everything happens underground, so it's not easy to see. If a river will turn blue or green, we will see it and report it, but groundwater is not that visible for let's say, wide public understanding, and very, very complex regulatory context, because, as I said, we're talking about surface water, we're talking about irrigation, we're talking about wastewater, we're talking about drinking water standards, and they are all together valid in the same project. So which regulations do we apply? Do we apply wastewater reuse regulations? Do we apply drinking water supply or irrigation? It's very difficult to say and depends on a case by case. So what is the actually ambition of the AGREEMAR project? AGREEMAR consists of two words, agree and mar, was to introduce what we call MAR agreements. MAR agreements are basically mostly non-binding arrangements. We also try to push, in some cases, for binding, so legally binding contractual arrangements between the key stakeholders who are either providing a service or benefiting from their service. And they define the rules, the roles, the conditions, responsibilities for each stakeholder. They also aim at balancing the interests of everybody involved. They ensure that benefits are shared in a fair way, and also it's for everybody involved, not just for a certain group of stakeholders. And also they should enable further development of MAR. Now, this is very ambitious tasks, because it's based a lot on voluntary commitment by stakeholders, but we have some examples, and I'm very glad we had Soufiane presenting before me, because we had in Morocco an example in the past. There are some publications available, the so-called aquifer contracts, where several stakeholders join forces and, let's say, voluntarily agree to jointly manage an aquifer. We have some other examples from Japan, where we are talking about payment for ecosystem services. So, for example, in that case, farmers which are not using their land as much as before, or they say they are getting older and the land is not used for agriculture, they are renting this land to the municipality to get flooded. It's mostly rice plantations, so they are already having the irrigation canals in place. So they are flooding the fields, not for irrigation, but for recharge purposes. So instead of buying land and maintaining an expensive infrastructure, as we've seen in the presentation before, managed aquifer recharge capital costs could be expensive. This is basically a transfer of the responsibilities to the farmers, who are basically doing nothing. They're just flooding their land, as they did also before when rice was cultivated, and getting money for it. And that is offsetting a lot of the capital costs. So these are examples of arrangements that motivated actually our AGREEMAR project. We started 2022, so this is our third year, and just 2 months left. That we are quite at the end of the project. We have 6 partners from Germany, Spain, Portugal, Tunisia, and Cyprus. Elena did a great job to introduce also a bit the objectives and our case studies. Let's say a classical PRIMA project with methodological development in different work packages and applications at different case studies. I will explain a bit the structure in the next slides. You see here that we are on, let's say, both sides of the Mediterranean, a bit on the south and the east, but also on the northwest. We have an example from basically the other side of the Mediterranean basin on the west of Portugal, but that is also, let's say, fitting into the same challenge. Agricultural intensification, there is extensive tourism in the summer in the coastal areas. That means a seasonal pressure on the water resources. There are MAR examples in all these 4 case studies, but either they are not working properly, there is public mistrust, or there is very small scale implementation. So we're trying to look at different scales. As Elena said, we're looking at the entire island of Cyprus as a potential case study. This is a very small watershed in the Capon Peninsula of Tunisia. We're looking at south of Portugal, quite large area, and even larger in Spain at the Júcar water district. The aim of the project was to develop a set of tools that help the co-creation or support the co-creation of the agreements. Yeah? So the final expected outcome is the, let's say, a 2-page document that is providing scientific evidence, it's providing guiding principles for the stakeholders to commit to developing MAR in the future. And for this, we need to collect this evidence. So we first started to understand who are the stakeholders. And we put quite a lot of efforts into this because we realize that this is crucial if we want to get this document signed at the end by the stakeholders. So who are the stakeholders? And we looked here at different dimensions. So you see here one example of a stakeholder map as was developed in the project. The different colors represent the different stakeholder groups. And we look at policymakers, let's say decision makers, and there are quite many of them. So each of them have something to say in MAR-Aquifer recharge implementation. That's why it's important to know them. We have practitioners, let's say organizations who implement these projects, and also civil organizations, NGOs, and so on. And they also have the scientific and research community who are supporting these decisions with scientific evidence. These are the colors, the red, yellow, green. Then we have the 3 concentric circles, which represent the scale of the stakeholders. On the dark blue in the center are the local scale stakeholders, and we have the regional scale, and then we have the national scale. Also very important, because MAR-Aquifer recharge sometimes is implemented at the local scale, but the decisions are taken much higher up. So we need to also understand both the horizontal dimension and the vertical dimension, the relationships between the stakeholders. And sometimes it's the same organization that has offices at all the 3 scales. So we need to also engage with all 3 of them. Last but not least, these slices, like a pizza slice, there are 3 of them, and they represent 3 main categories that are relevant for us when understanding the feasibility of MAR-Aquifer recharge. First of all is the water demand. So we're talking about different sectors. I mentioned before tourism, agriculture, and in some cases also drinking water supply and competing interests. We're talking about water availability, and we are looking at conventional and non-conventional water sources. And we are looking also at the intrinsic suitability, so geology of the area, morphology, topography, and so on. We built these maps for all 4 case studies, and the second step was to cluster the stakeholders based on their interest that they show for the project and or potential influence in decision making. And based on these 4 categories, we design specific engagement plans. For example, the type of engagement. So how do we really communicate with those stakeholders? Now, I'm a civil engineer and I'm more on the technical side, but I'm trying to understand and to learn how to communicate properly our research, because I think there is a lot of research done in many projects, and you agree perhaps with me, but there's a very small portion of it implemented. Because also, I think the guilt is on our side as researchers. Perhaps we're not, let's say, communicating our results properly. We're not using the right tools, and we're not perhaps talking to the right people. So we're trying to learn. I'm not so sure if this is successful communication, but trying to learn how to, let's say, share our results and how to integrate the opinion of the stakeholders. And this work package 1, actually, you will see here also in the beginning of the project, is a project that is a package that interacts with all the other packages. So as in perhaps in your project as well, we try to support all the scientific work by engaging the stakeholders. So definition of the problem, definition of the objectives, co-designing the methodology, refining the methodology. All this has been discussed in extremely many interactions by the local partners, by the project consortium as a whole, and so on. The results are published in project deliverables. All of them are available online on our website. How this stakeholder analysis was done, how we created these pizza charts, what is the detailed engagement plan, as Soufiane also presented in the other project, and also what kind of tools did we use to create awareness and to reach out to the right stakeholders at the right time. Now, we are now with this knowledge, we are starting to build the feasibility map for managed aquifer recharge at that regional scale. So we have our cases are not locations, but rather regions. And for this, we followed a simple approach, let's say producing a map that shows areas where managed aquifer recharge could be in the future, let's say, considered. And we designed some general guiding principles following the AG-WaMED principles, considering different sets of criteria. There are over 150 feasibility criteria collected and discussed with the stakeholders. Of course, the maps are not using 150. We're using, let's say, way much less, but we try to let's say, harvest all the concerns and all the considerations of the stakeholders. That's why we build this matrix covering a very broad range of considerations. With this detailed, let's say, approach, we built 2 sets of maps. One was built by researchers, let's say, with our understanding, with our scientific bias, and one we built with input from the stakeholders. And then we merged these 2 maps. We noticed that in some cases there are some small differences, in other cases there are quite big differences. So the perception of the stakeholders is sometimes completely different than our scientific, let's say, understanding. So also, again, very important for us was to get this valuable feedback from the stakeholders in all the scientific steps. The maps are published, some of them in articles, some of them are under review. There are some reports on the methodology, how we created these maps, and also how we validated the maps at each case study region. And speaking of validation, the maps gives us qualitative information where exactly in this region we should focus more, but the more quantitative information we get from ground water flow models. And here again, we reach out to stakeholders and design the objectives of the modeling together with them. They told us, for example, in Tunisia, they asked us to to study different MAR configurations to try to assess the potential solutions for restoring depleted groundwater levels, which is more than 20 meters close to the coast. And I also totally agree with the presentation before. On the coastal zones, we have high potential for MAR, and the models were supposed to also demonstrate the capabilities of MAR in reaching different targets. In Cyprus, we looked at recharging treated wastewater and looking at the impact on the surrounding production wells. So we have drinking water wells and irrigation wells. So what is the benefit of MAR in terms of water quantity and quality to those wells? And in Portugal, we look at upscaling the existing MAR system because it's just one wastewater treatment plant infiltrating the tertiary treated effluent. But in terms of quantity, that doesn't make a huge difference because the volumes is very low. So we try to convince stakeholders with a regional model to connect further treatment plants to the system so that more water will be used in agriculture instead of being discharged into the surface water bodies. Together with the stakeholders, I emphasize again this, we build, for example, in Cyprus, the conceptual models. We try to understand from them, and we had a 2-day workshop only for this, what are the elements that are relevant in the water balance in the region, which are the inflows, which are the outflows, what is the location of each of those elements, and what is the trend, how this will develop in the future. So all these conceptual models were built in workshops together with the stakeholders. And for the implementation, for the numerical implementation, we're using our own software, which is a web-based groundwater modeling platform. And the tool, we have several tools. The tool that we're using is a completely new ModFlow interface. That is the most common, let's say, code for groundwater flow simulations. And here, 2 examples from Portugal and from Cyprus. We're just looking at this map. This is a map showing the groundwater piezometric heads in the study area. You see here the impact of the managed aquifer recharge system, just visual impact. And we have all these raster files and trying to simulate all these scenarios. This is now under preparation for a publication. In addition to the groundwater flow modeling, which is basically the aquifer system at a local to regional scale, our partners from Valencia also used the water location and distribution model. It's also in-house software called AquaTool, where we look at much larger scale. So what is the impact of managed aquifer recharge at the basin scale, considering all the stream flows, existing reservoirs, water users, and so on. So we have 2 modeling approaches at local and small, let's say more localized scale and larger basin scales, trying to understand both impacts. Also, this work is published. What I want to emphasize here, okay, there are some embargoes on the publication because we want to get out the papers first. But when we try to communicate these results with the stakeholders, we realize that this is a report with 130 pages. And we realize that no stakeholders ever in the world will read 130 pages in English and then learn something from it. So we provided each stakeholder with a 4-page document. Actually, this is depending on the case by case, but let's say no more than 4-page document written based on their needs and not based on hydrogeologists' opinions. That means we went back to the stakeholder mapping, we reviewed their needs, and they were very simple. One stakeholder asked, for example, if you want to put more water into the ground, how much you can do, how much you can put. It was very simply formulated. So we tried to translate results of the model into very basic answers for the stakeholders. And this is something that we don't do very often. We just provide presentations and reports to them. But in this case, we just provided 4 answers. And it was also very well received. So for us, it was a lessons learned that we try to apply also in the next projects. Another tool, because we're talking now about agreements, so we're not just talking about one outcome from a model, but basically supporting stakeholders to understand the role of managed aquifer recharge. We use the so-called constellation analysis. This is more applied for, let's say, the social sciences, but we have here a wealth of information, and it looks very complicated, but these diagrams also have been developed together with the stakeholders. So what we have here, we have, first of all, the stakeholders themselves. We try to put all of them on the map. It's an example from Portugal in relationship to the case study. So the case study is here in the middle, and how they relate to the case studies. Some of them directly, some of them indirectly. What is the regulations? What is the regulatory framework? What are the, let's say, limitations in terms of applicability of the solution? What are actually the solutions? So what are the contributions of managed aquifer recharge? You see, for example, increasing water availability, discharging treated wastewater, storing seasonal storage, and so on. These are the technical services. We have the receiving bodies, let's say the local streams, the coastal aquifers. These are the natural ecosystems that benefit from our technical solutions. Our project results, so where exactly can we intervene with our project and what kind of contribution can we bring? And also what are the external threats and limitations in terms, for example, of decreasing water availability or increasing the climate pressure, for example, length of the dry spells and so on. This diagram itself, it's complicated, but the way to discuss with the stakeholders and all those interactions were very valuable because we could understand better what actually happens at the case study beyond just, let's say, a groundwater flow equation. So it puts into one picture all the, let's say, technical and non-technical elements of a case study. And this also was very helpful for us to designing the text of the agreements. The results of the work package 3 includes an analysis of indicators and methodologies that was needed for us to review, to extract maybe best practices. Design this governance framework, which is it's more like a guidance document for all the case studies, and then extract 4 sets of regional agreements for each demo region itself. And then we went back to the stakeholders for formulation of the text. Imagine we have to bring all this wealth of knowledge into 2 pages. So there are different interests. Each stakeholder wanted to promote their own, let's say, paragraphs. And there was a lot of interaction to try to bring everything into a common ground, into some sort of language that is accepted. Because some of them said, we are not signing a binding document, but we are able to sign and willing to sign a declaration or, let's say, a charter. We have different languages, different terms, because we talk about different languages. So this word agreements was translated differently in all the countries. And we had a lot of training also into numerical modeling, into feasibility mapping, into this watershed modeling, because they wanted to learn also the tools. How did we reach this conclusion? And we were happy to have the opportunity to provide training course on groundwater flow modeling. That was not that often the case because the stakeholders, they don't do modeling by themselves. But in case of Cyprus, these photos from one particular training course we had there, the water authority wanted to learn mod flow, and we used our web-based software for that. And last but not least are all the other, let's say, minor contributions from social media, from newsletters, from different flyers, brochures, as as we have in all the projects, translate them in local languages, so trying to support also and promote the information from the project. The deliverables from the last package include a detailed action plan that we built at the beginning of the project, so using the proposal as a reference, but then the subtasks, a much more detailed Gantt chart and so on. We have a data management plan because we are collecting a lot of data and we don't want this to disappear, and in the next project we have to search for the same information and again and again. We had two big project meetings so far. The third one, as I said, is in AG-WaMED by beginning of April, so very, very soon. And what we aim at the end is to get some sort of document supported by all these tools. So this looks a very nice, clear diagram, but in reality, it's a mess. Mess in terms of very complicated relationships and connections between the stakeholders themselves, sharing the responsibilities for different tasks. Very often we hear that, no, the other ministry is responsible, or that's not it's the local organization, or this is coming from the national level. So it's not the stakeholders that are very much interconnected, but also the tools that we provide. So we are trying with the project to let's say, support this decision making with some sort of principles, and they are going to be formulated right now in these agreements. And we have draft text for all four. We already had this week even one of the workshops in Cyprus where we try to agree on a final version, and hopefully by the end of the project we will have these declarations signed by all the key stakeholders involved. 10 seconds, one slide advertisement. There is a quite large conference on managed aquifer recharge where our project will also provide a side event, a workshop. It's happening in South Africa by the end of April. And if you are interested, it's still possible to register, but just only for a couple of days more. So feel free to check the website, and maybe if you're already participating, I look forward to meet you there. As was mentioned before, the project is funded in the section 2 of the PRIMA call, and we had funds from the German, Tunisian, Cypriot, Spanish and Portuguese governments, as probably the case also in the other projects. Our website is agreemar.innovas.com, and these are also my contact details if somebody would like to follow up, and I look forward to your questions. And thank you very much again for the opportunity to present the AGREEMAR project in this webinar.
Thank you very much, Catalin, for the great presentation on MAR and on the project. I'm going to open up the floor to questions from the audience. Maybe I have one question. I'm particularly interested in the development and the signing of the MAR agreements. Was the agreement hosted by an institution, by a local institution, or how did that work, the signing of the agreement?
Very good question. Thank you. The start was very, let's say, broad. So we were trying first to build confidence. First of all, build the confidence in communicating with the stakeholders and including them from the beginning in the whole process, because we thought this is going to make our mission at the end easier than just, let's say, coming for the first time or the second time with the paper to be signed. It helped a lot to engage them and explaining the scope of the project since the very first meeting. Secondly, we realized that there are very different interests and very different powers implied in the different case studies. And when we talk about interests, we have national stakeholders. For example, in Cyprus, that are taking the decision at local level. In Cyprus, we don't have local stakeholders. So basically, we had to engage with the national authority. While in Portugal, it was the other extreme, it was rather the local stakeholders, because the wastewater treatment plant was bringing a very local impact. So we had to adapt a lot the strategy by scale, by interest, and also by expectations. For example, the scope of this agreement was different. In Cyprus, the scope was more like let's say, highlighting the topic of managed aquifer recharge for future expansion of the system. They are already ongoing projects, and we mostly engage with one main stakeholder, because they are in charge of those. There are two running successful MAR sites, so we engage with one. In Tunisia, for example, we have several MAR projects running, and one is in our project is included as a case study, but the diversity of the stakeholders is much more heterogeneous. So we had interests, local scale, regional scale, national scale, from different farmer associations, water municipalities, and so on. So we had to engage with more. That means there are more signatures, and the objective is rather a roadmap. So let's say it's more like a step-by-step approach for the future. In Spain, in Portugal, it's also quite different. So it's not easy to apply one general approach for all of them. We realized this during the project, and even the terminology is different. In French, let's say in Tunisia, it will be called charta, like a carta, which is more or less non-binding paper. But in Cyprus, it will be called a declaration. So these are local minor differences, but for me, I mean, it's just a word, but for the local stakeholder, that was a huge difference. And we spent actually a lot of time just to define this title. So a complete different challenge than, let's say, model calibration or all these kind of technical issues. Sometimes the decision comes how to put that word. And that seemed to be what we learned from this project, that sometimes it's more important than all these scientific efforts and publications that we do. But the idea of the project is to combine both. In that paper, which is more or less a governance, let's say a strategical governance paper, all this scientific support is flowing in. So it's supported by evidence, and it's providing them also with some tools how to increase confidence and how to build managed aquifer recharge projects.
Thank you. Because as part of the AG-WaMED project, there are different living labs, and we're trying to assess which options we have to continue the activities of the living labs beyond the duration of the project. And we were thinking for the Taia Living Lab, there are different ways we can form an associations, or we can sign a river contract or a letter of intent. So it was good to hear your experience on this, on how you formalize some of the discussion and the results of the project. Thank you. I think we have a questions from Rohina Bauer.
Yes, hello everyone.
Hello.
And so my question is, as a student, I'm just proposing forming a consortium, because as you see, these countries and stakeholders, they can come together and establish a task force dedicated to both conventional and non-conventional water conservation. So it can have a clear agenda and also can give legal aspects to ensure water safety. So as this idea, I mean, I think that can help, like, because you have a local level idea and you get experience from the local level, and another is a stakeholder level. So does AG-WaMED or WaMAR currently have a consortium, or they have a plan to establish one? Thank you.
I don't know if the question was addressed to me or was rather general. From my perspective, it's very important to talk to the stakeholders, and that's, I guess, it's a common sense already for many projects to talk as early as possible. One particular example from Tunisia, the stakeholders asked by themselves to form a steering committee. We plan to have steering committee at the general project level, but not at the local level, and they ask for that. So they ask us more or less, not permission, but inform us that they want to build a steering committee and have regular meetings. So these sort of committees, I think, are very important to keep regular meetings, to keep the things ongoing, and not simply just random visits and let's say sharing final reports. There are also working groups at different levels. I lead a working group, I lead a commission, let's say like that, on Manachak Charge at the level of the International Association of Hydrogeologists. This is more on the technical level. And there are also networks and working groups there. Stakeholders can join those working groups. There is a working group on communicating scientific research to UN institutions, United Nations institutions. That's a bit higher goal. So yes, I think it is a good idea to create local networks to engage a variety of stakeholders, not only the authorities, but also the beneficiaries. Farm associations, for example, they wanted to be included in these agreements. They wanted to have their voice there, and they were willing, let's say, because one of the questions was costs, and what we were asked to include is the willingness of farmers to pay more for the water if the water quality is improved. So another lessons learned from me was that when I talk about stakeholders, we should look at both sides, those who provide services and those who use the services, and try to bring them all together. Maybe someone else has a better answer or a different perspective. Not so sure if I address your question properly.
Any other questions from the audience? Okay. Maybe because we are a bit ahead of schedules, what I could propose is we take a short break before we go on to the next session. Just a 10 minutes break, and then we are gonna leave the call open, but we just take a little break for everyone to refill their cup of coffee, their cup of tea, and but let's wait maybe a few more questions from the audience or not. Well, if they come up during the break, we can take these questions after the short break. Okay. So let's say that we reconnect in at 11:15, so in 12 minutes. You can stay on the call, of course. I'm going to leave the call open. Okay, let's go on a short break. 11:15, we are back.